Welcome to Geomechanics 1. The second section of this unit is Geological Processes. We will introduce this section from 5 different video clips. At the first video clip, we will briefly discuss fundamental concepts of engineering geology. Here you can see the content of the geological processes. We will discuss details of earth composition, earth interior process such as formation of igneous rock, intrusive and volcanic plate tectonics, Earth's exterior surface processes such as weathering, erosion, sediments, sediment rocks, and finally, how these concepts can be applied to civil engineering projects. We will discuss the importance of geology in engineering, factors controlling engineering properties of rocks, and geological maps in civil engineering in this section. As you can see in the figure, Earth has multiple layers. Core, mantle, and crust are the three main divisions based on the Earth composition. The crust makes up less than 1% of Earth by mass, consisting of oceanic crust and continental crust. The depth of the crust varies up to 100 km. The thin parts are the oceanic crust, which underlies the ocean basin and are composed of a dense iron magnesium silicate igneous rock such as basalt. The thicker crust is the continental crust, which is less dense, composed of sodium, potassium, aluminium silicate rocks like granite. The crust is divided into huge plates that float on the mantle, the next layer. The plates are constantly in motion. The mantle is hot and represents about 68% of Earth's mass. The mantle under the crust is about 2,900 kilometers. It is composed mostly of silicate rocks, rich in magnesium and iron. Intense heat causes the rocks to rise. Then they cool and sink back down to the core. This convection is thought to be what causes the tectonic plates to move. When the mantle pushes through the crust, volcanoes erupt. Finally, at the center of the Earth is the core, which has two parts. The solid inner core is made from iron metal. The inner core spins at a different speed than the rest of the planet. This is thought to cause Earth's magnetic field. The inner core is surrounded by liquid. Outer core composed of nickel iron alloy. The core makes up about 31% of the Earth. The lithosphere and asthenosphere are divisions based on the mechanical properties. The lithosphere is composed of both the crust and the portion of the upper mantle that behaves as a brittle rigid solid. The asthenosphere is partially molten upper mantle material that behaves plastically and can flow. The Earth's lithosphere, which includes the crust and upper mantle, is made up of series of pieces or tectonic plates. These plates are huge slabs of the Earth crust. These plates are constantly moving at a very slow rate. They move only few centimeters per year. Sometimes the plates collide one another or move apart. In this figure, you can see the world map of plate boundaries and active volcanoes marked in red color. You can see that almost all of the active volcanoes are located along plate boundaries. The Ring of Fire is a path along the Pacific Ocean characterized by active volcanoes and frequent earthquakes. 75% of Earth's volcanoes are located along the Ring of Fire. 90% of earthquakes occur along its path. The two types of plate boundaries that are most likely to produce volcanic activity are divergent plate boundaries and convergent plate boundaries. Transform boundary, where plates move sideways past one another, generates large number of earthquakes as tension in earth crust builds up and is released. Let's look at the details of these plate boundaries in the next couple of minutes. A divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, earthquakes are common and magma rises from Earth's mantle to the surface, solidifying to create new oceanic crust. When two plates come together, it is known as convergent boundary. The impact of the colliding plates can cause the edges of one or both plates to buckle up into mountain ranges, or one of the plates may bend down into deep Sleaford trench. Thus, at convergent boundaries, continental crust is created and ocean crust is destroyed. Two plates sliding past each other forms a transform plate boundary. Earthquakes are common along these faults. Rocks that were originally deposited in horizontal layers can subsequently deform by tectonic forces into folds and faults. Faults constitute the twists and bends in rocks. Faults are results of the ductile deformation of rocks in response to external forces. Layered rocks folded into arches are called anticlines, whereas troughs are referred to as synclines. Rocks that undergo brittle formation tend to fracture into joints and folds. A joint is a crack in a rock along with no appreciable movements has occurred. Fault is a plane of dislocation where rocks on one side of the fault have moved relative to rocks on the other side. Faults can form in a response to any one of three types of forces: compression, tension, and shear. A fault plane divides a rock into two blocks: the hanging wall and foot wall. This terminology comes from mining. When working tabular ore body, the miner stood with the foot wall under his feet and with the hanging wall above him. If the hanging wall slips downward relative to the foot wall, the fault is defined as a normal fault. Normal fault results from tensional forces. Compression forces typically push the hanging wall upward relative to the foot wall, producing reverse fault. Shear forces typically produce strike-slip faults, oblique faults, where one block slips horizontally past the other. We need some way to describe orientation of rock layers. So we use the term dip and strike to describe the orientation of rock layers. The dip is the acute angle that a rock surface makes with horizontal plane. The strike is the direction of the line formed by intersection of a rock surface with a horizontal plane. Strike and dip direction are always perpendicular to each other on a map. Here we have a tilted rock layer. We call the rock layer is dipping at 30 degrees. A very easy way to understand what is the dip is to imagine that it's rainy and the water is dripping down the rock. The direction of the water is dripping is the dip, and the dip angle is measured from horizontal surface. As you can see, the dip is indicated in terms of angle and the direction, which is known as dip direction and the dip angle. We also want to describe the direction in which the rock layer tilted. The compass direction relative to the north is given by strike. In this example, the strike is described in terms of direction such as 40 degrees from north. Here you can see some more review questions that you can practice. I hope now you can answer all these questions. So that's the end of this section. We will continue geological process lecture with 4 more clips that introduce igneous rock, sedimentary rocks, metamorphic rocks, and application of that geological knowledge.